voice clear? Today is the concluding class for Macaulay's method. Last class. From today onwards, double integration method. Macaulay's will be considered next time onwards. Okay. See, already I told you, this is the beam. I have not removed it yesterday. If A is the origin, single origin will not work out because, see, if you take a section here from A to C, that is 0 to 4, BM will be 36 into X. If I start from here, the moment I go beyond C, BM will come 36 into this distance, minus 60 will come. So, if I go this way, up to C, only 36 will come. The moment I go beyond C, 60 will come. So, this equation is valid only for AC. Same way, see, this equation is valid only from B to C. So what you have done? A origin section between A and C, X from A. B origin section between B and C with what? B and C and C origin, B origin. This varies from 0 to 4, 0 to 6. You can use this one for any value up to 4, including 4. Beyond 4 you can't use. Other side equation, beyond 6 you cannot use. See, now this will give a lot of trouble. All these difficulties, everything will be taken care by Macaulay's method, where even if any number of loads are there, or any, see here, C1, suppose imagine one more load is there, then you require 3 sections, and C1, C2, then again C3, C4, again C5, C6, that way it will come. Therefore, work will be very lengthy in double integration method. Everything will be eliminated in Macaulay's method, where just one section. How? Take A origin, take section here, look this side. But of course, if the section is here, 60 will not come. That will be adjusted in the equation. So therefore, some range will be there. So all the difficulty we are facing in double integration method will be eliminated in Macaulay's method. Tomorrow we are starting Macaulay's method. So study point of view, double integration method, don't concentrate too much. What all we solve by this method, same. See, I wrote already. C1 has to come, I write here. This is the advanced answer I given. Your C1 has to come minus 384 and your C3 has to come minus 336. This I told yesterday and I checked it also. No, still we didn't get it. We are getting it now. That is advanced answer given. How I gave the answer, you never bother. For that matter, for this complete beam, within 2 minutes or 1 minute, everything is possible to solve. That trick you will learn only for competitive examination. Okay, start. Now, see, for AC, equation for slope and deflection over, remember, see I wrote here. For BC also, for AC, X from A, for BC, X from B. Okay, now very, very important. To get, see, this is where you have trouble. Constants of integration, that is what? See here, C1 and C2 for your AC portion, and also C3 and C4, this is for not CB, because you come from this side, for BC portion. Okay, this you have to get. So 4 unknowns are there. So you require 4 equations. You can make a note here. Make a note. There are 4 unknowns. Which one? C1, C2, C3, C4. But therefore, we require 4 equations. Unfortunately, only 2 equations are there. See right here. See, don't see original. When you apply a load, beam will bend like this. So here it is A, this is B. Deflection at A0 and deflection at B0. This is known for you. Therefore, Two equations are available. You have shortage by 2. I told you, if it is analysis of structure, we call indeterminate. Here, something you have to do. That is the drawback of double integration method. When point loads are there, if UDL only is there full span, then both methods are same. Okay, now, see correctly, right here. 4 unknowns are there. You write all these. Only 2 conditions are there. See, center last time, I wrote theta equal to 0. No. Why? Your point load is here. See, deflection is maximum somewhere here. We don't know where is the maximum deflection. If you know where is the maximum deflection, you can write theta equal to 0. We don't know it. Therefore, only 2 conditions. So, extra 2 conditions are required. So, right here, operating all these, right, let us first use above condition, above 2 conditions, which are, that is what? Deflection at A0 and deflection at B0. First, we will use this one. Write a note, I am removing. First, I will use the condition, deflection at A0, deflection at B0. Use it. Okay. I will remove this one. Why? Space problem. So, first I will consider, find YA0, I will consider YA0 and YB0. Okay, start. First, see, first condition, sketch. I already put the sketch there. Write the sketch. Or, I will write one more sketch for you. See, the elastic curve for the beam will be like this. See, this is the point load here. Therefore, this is A, this is B, this is C. It will bend like this. Therefore, see here, maximum deflection will come somewhere here. Why, I will tell you little later. Now believe me. So, here see, this is Y. Y at A0, one condition. Y at B0. That's all we got. Now, something extra you have to write. You tell it. Please wait for some time. See, I am going to add something else here. Time being, you write this sketch. Okay, start. First, consider Y at A equal to 0. That means Y at A means what? See, somewhere here. Therefore, Y becomes 0 for X equal to red color. Actually, that is not required. Okay, English. For Y equal to 0 for X equal to 0. X equal to 0, very important. Substitute in deflection equation. See, there is one deflection equation for AC, one equation for BC. When you put X equal to 0, you are here. So, deflection equation for which one? Equation for AC portion. You cannot use this equation. Because why? This is the equation for B to C. Okay, start. Here, this equation. 0 equal to C1 into 0 plus C2, then 36 into 0 cube by 6 into 0. Therefore, C1 plus C2 plus 0. So, this is 0. See, 0, 0. Therefore, we got C2 equal to 0 over. So, therefore, your term C2 became 0 over. Now, right, that's all condition we got from A to C. Why? At A, deflection 0. As you go towards C, deflection keeps on increases. Okay, slope is there at both points. No more condition. Okay, right. Now consider Y at B equal to 0. Here Y equal to 0. That is, your Y becomes 0 for, once again remember, B means you have to use this side equation. So again, Y becomes 0 for X equal to 0, but substitute in deflection equation for not AC, for this way, BC, for BC, not this equation, start. 0 equal to C3 into 0 plus C4, then plus 0. Therefore, your C4 equal to 0. Over. So I told you C3, C4, 0. Right. Now write. That's all. That's all we get. That's all what? Conditions or boundary conditions we know. You write there. That's all. No more boundary conditions are available. Why? Because here deflection 0, here deflection 0. Everywhere else deflection is there. Here slope is there, here slope is there. Slope is, here also slope is there. Somewhere here slope is 0, but where? We don't know where. Unless you know where, how you can consider it? Therefore, right, that's all we got. Right here. That's all we got. Now, right, therefore, we need some extra principles now. That all you have to write. See. So remember now, I'll write here now bold letters. What we got so far? We got C2 equal to 0, and also we got C4 equal to 0. C4. Sometimes what happens is by mistake, I may write C3 there. See. 0 equal to 0 plus C2 plus 0, C2 0, 0 equal to 0 plus 0 equal to 0 plus C4 plus 0. So we got now C2, C4, 0. Still pending. Still pending. Which one? In the AC equation, C3. In the BC equation, C4. Tell me. This much clear now? Fast tell me. This much fully clear? This much clear or not? See, these all troubles are going to be eliminated in Macaulay's method, where you will be so happy, no confusion. You put x equal to 0, y equal to 0, x equal to 10 meter, y equal to 0, over. It will take care. The equation is written in such a way that the equation is valid for not only AC, also for CB. That is the advantage of Macaulay's method. But here, helpless. Okay, now, therefore, right here, therefore, we need two more equations. Two more equations. Right. Boundary conditions are not available. Therefore, something special you require. Special. They are, what you do is, see, continuity condition. Continuity. Or now go to elastic curve. See here. In the elastic curve, this is deflection at C. See this much. I am not showing arrow mark. I am not showing arrow mark. I will put double arrow mark. Why? Sign I will put later. This is the distance. Deflection at C. And if I draw a tangent here, see, to elastic curve, this is double arrow mark. Slope at C. So therefore, remember, theta C and yc are slope and deflection at C. Here, direction not shown. Direction not shown for some reason. Because if I show the direction, if I use sign convention, it becomes mathematical blunder. I never commit mathematical blunder. See, I never commit mathematical blunder, which you can see a little late. A little late, you can see it. Right, I wrote here. You can see little later. Little later. Oh, okay. Oh, like that. Leave it. Start. Now, what you do is find theta C and yc two times. Two times. Find both of them two times. How? Two times means, see, how? Once using expressions for AC portion, and then using expressions for BC portion. Right here. One note you have to write. See, all I am removing. Note. Yes. C is the end point of AC. So x equal to 4 from AC. Note, when you consider AC, C is the end point, end, for which x equal to 4 meter. Okay. Same way, when we consider BC, x from B, again C is the end point, but x equal to 6 meter. Over. And this equation is valid from A up to C, including C. That equation is valid from B up to C, including C. Therefore, both the equations are valid for x equal to, for the point C. Here x equal to 4, there x equal to 6. Tell me, this is clear? Only C is the common point. Why? End point of this side, end point of that side. This side you put x equal to 4, you get answer at C. That side you put x equal to 6, you get answer at C. So therefore, clear or not? First, clear. Therefore, find what? Find theta C and yc both twice. Then for continuity, see, you can write here. Then for continuity, theta C and yc should be same for both. Should be same. See here, this is the deflection at C. Whether you see the elastic curve here, it hardly matters where you take x from. So this is yc. This is yc for x equal to 4 from this side. This is yc for x equal to 6 from this side. If you want, right here. This is 4 meter. This is 6 meter. Same way. This is theta c for x equal to 4 from here. This is theta c for x equal to 6 from there. Tell me, this is also clear? First, I am not going to explain again because why? Because we are going to Macaulay's method. This you are forgetting. After tomorrow you will not do this method. But this is a basic method. Clear? Clear or not? Yes, okay. Now start. Now I will calculate. Don't ask any question now. This is all I told. Start. I told you, little later you can see what? How mathematics is important. I will tell you it later. Reason is there. Remember, I already wrote C1 and C3. That means I am solving now with the answer already given by me. Okay, start. Now, first, consider AC. Consider AC. Okay, start. Consider AC, x from A varies from 0 to 4. Correct? Here, substituting x equal to 4 meter, what you do? Find the value of theta c and yc. Why? When you put x equal to 4 meter, you are getting theta c and yc. Start. So, substitute x equal to 4 meter in slope equation. Slope equation. Where is the slope? Where? Slope equation for AC. See, EI theta c. You get EI theta c equal to C1 plus 36 into x square by how much? X square by 2 is 4 square by 2. EI theta c. And substitute x equal to 4 meter in deflection equation. Deflection equation. Okay, start. You get EI yc equal to C1 into 4, C1 into x plus C2 is already 0, right? Plus, okay, C2 already 0. Then plus 36 into 4 cube by 6 over. This is EI theta c. Do one thing now. Now, come this side. Okay, now, consider, you tell it, you please, both of you, wait for some time. Wait for some time. Okay. Wait, I'll come to you back. consider BC portion. Consider BC portion. X from B, where is from 0 to 6 meter. Then what you do? Substitute x equal to 6 meter, and what I do? I written here. Find what? Find once again theta c and yc. Okay, start. Substitute x equal to 6 meter in slope equation. Which slope equation? Slope equation for BC. This one, not that one. I wrote consider BC means this equation. Start. EI theta c once again equal to, see, EI theta c equal to C3 plus 24 into 6 square by 2. You tell it, hey, please wait for some time. You also, please, this will tell, I am already waiting. Okay. I am also already waiting. Okay, wait for some time. Then substitute x equal to 6 meter in deflection equation. You get EI, this is that side, okay. EI, where is here? YC equal to C3 into x. C3 into 6 plus C4 is already 0. C4 is 0 plus 24 into 6 cube by 6. This is your, see, this is EI theta C, EI YC from left side. This is EI theta C, EI YC from right side. This is end point of, this is the result for end point of AC. That is the result for end point of BC. End point of AC from this side and end point of BC from that side, both are same point. There, only one slope is there, one deflection is there. Write everything. Once again write. All I told right now. Tell me. Lastly, clear? If clear, over. Now then nothing much. Then some principles. Last I want to clear. Someone should write clear now. Yes, clear. Okay. Now, very easy. What to do? Write a note. Whether you, see, you write here, whether we consider AC portion or BC portion, C is the common point, irrespective of this side or that side, answer is same. Therefore, equate EI theta C and also EI YC from both sides. That is what? You write here. That is EI theta C we get for AC equate to EI theta C we get for BC, and also EI YC we get for AC equate to EI YC we get for BC. Then I think I need some space now. I'll write here now. Therefore, see, from there I am coming here. See, continue. Therefore, start. EI theta C we got C1 plus 36 into 4 square by 2, that should be equal to C3 plus 24 into 6 square by 2. If you simplify, what will happen? You will get C1 minus C3 equal to, tell the answer, 24 into 6 square by 2 minus 36 into 4 square by 2. Take this number this side, this number that side. This one let it be here. This one take that side. Answer. 24 into 6 square by 2 minus 36 into 4 square by 2. Answer. Fast answer. 24 into 6 square by 2. 24 into 6 square by 2 minus 36 into 4 square by 2. Someone told maximum BM under the loads. I know it. That is not required for us. Maximum BM under the load is of no use for us. That is WAB by L. I know much about bending moment also. Tell the number. 24 into 6 square by 2 minus 36 into 4 square by 2. Answer. Fast. Number. See, C3 being this side. This one take that side. 24 into 6, 144 equal to 144. You call equation number 1. One new equation. Okay. Start. Once again. One new equation. Then second time. Also, what you do? Equate EIYC here to, this is what? This is equating EI theta C on either side. This is next one. Next what? Equating EIYC on either side. What do you get? Here. C1 into 4 EIYC. C1 into 4 plus 36 into 4 cube by 6 EIYC should be equal to there C3 into 6, C3 into 6 plus 24 into 6 cube by 6, or tell the answer 4C1. What do you get? Here 4C1 minus 6C3 equal to, tell the number, 24 into 6 cube by 6 minus 36 into 4 cube by 6. 24 into 6 cube by 6 minus 36 into 4 cube by 6. Once this C3, C4 is over, remember, we are going to important principle valid for double integration method, Macaulay's method, conjugate beam method, moment area method, not this method. Some important principle I am covering. Once the C1, C3, because I want to rub the full board, I will maintain these two equations. This full I will rub. Number 480 equal to 480. 480. Okay. This is equation number 2. Now, fast solving 1 and 2, get the value of C3 and get the value of C1 and get the value of C3. Answer. Solve 1 and 2. Fast. C1 minus C3 equal to 144. 4C1 minus 6C3 equal to 480. Solve 1 and 2 and get me C1 and C3. Fast. How much C1? Solving 1 and 2, get the value of C1 and C3. Tell the answer. Solving 1 and 2, tell the value of C1 and C3. C1 answer. Fast. C1. Solve 1 and 2. You don't require calculator. You can multiply by 4 and subtract, or use calculator. C1, how much? C1 is 192 and C2 48. Tell me, correct answer? No, I want more people to give answer. Is the correct or not? 192 and 48, I don't know. If correct me, tell me. I want confirmation. No. When I solve 1 and 2, C1 192, C2 48, is it coming or not? This much time. No. How much comes? Then tell me how much it comes. See, my calculator is not here. For some calculation in the morning time, I was writing some problems for another subject. That time, that ETAP class, I forgot it there. Okay, tell the answer. How much it comes? Again, see, you are unnecessary wasting time. Now you are forcing me. You should follow what I tell. You made me unnecessary to go and come back. You solve 1 and 2 given by me. Answer. I told you do not apply any correction solve. What 1 and 2 I got, you solve it and give the answer. How much C1, C2? Solve 1 and 2 given by me, C1, C2. You are again, don't do any corrections like that. Whatever I have given equation 1 and equation 2, solve that one and give me C1, C2. See, how you got 384 and 336? Solve 1 and 2. Don't apply any correction to my class. C1 is 192, C2 is 48. Clear or not? Fast tell me. Fully clear or not? Fully clear or not? Fast tell me. C1 192, C2 48. Just tell me clear, I'll go to the next step. No comment. Clear. Okay. Now, but yesterday only I gave you C1 and C3. See, I told C1 is minus 384, C2 is minus 336. I verified it also. Verification is not a problem. I can check it once again if you want. What is there? Not a big issue. C1 minus 384, C2 minus 336. See, I once again got it. How I did it, you don't ask me. You never try how he got so fast. That all beyond your capacity. So yesterday I told this answer. Today once again I told the same answer. But you are not getting same answer. This answer right here, this answer does not tally with those values which he means write my name. You write KSN, no problem. Which KSN told yesterday. And yesterday he told with confirmation. And what he tells, how much answer he tells should come in structure analysis. If it is not coming, class will not continue. There will be a stopping of my class. In future, I will not take any class in my life. Okay. Now, therefore, there is, write all these things. Write everything for an. See, this is how you get the grip. You everything I told today, you write it. Then write. Then what answer he told, he did not get that answer. And he told, if we tell some answer has to come this much, if it is not coming, then he told he will quit teaching. But he will not quit teaching. He will go that side and come back and continue. Now you have to repair it. Therefore, there is something seriously wrong. I told mathematics is important. I told you can see it later. Yesterday I wrote something here. Do you know what I wrote? I wrote, I know that one. I am not that much weak. This is only deliberately I am making a mistake. I forgot it. I wrote it here. Some A, F, B, D, H, all. I wrote there. I know all these things. Because otherwise what will happen is, somebody will correct me, then he will keep on telling everywhere. KSN made a mistake, I corrected. Let him know, I know it already. This is a deliberate mistake done by me, so that you will learn the concept. Okay, I'll give you 5 minutes time for you to repair and get C1 and C3. One person already got. Who? See, one person, I know, when he wrote the answer, see, Nanda Kumar already got same answer, correct answer. I ignored because if I talked with him, that is what mistake I am making, he understood that one. He made correct, he solved correctly. So one person got correct answer. Now, no, you got correctly. I only told that answer should come. I made a mistake deliberately here. So now I'll give you 5 minutes time and you already got. What to get now? You already got. Other solve. Take a pen, nothing there. One small correction and tell me. I'll give a hint and go. Before going, small break. I'll give a hint and go. See now. One small hint I'll give you. This is theta C, this is YC. See here. Correctly see here. Whether you take left origin or right origin, You write here, irrespective of taking left origin or right origin, deflection is always upward positive. See, here also upward positive, there also upward positive. But when you take left origin, your theta is anti-clockwise positive. When you take right origin, your theta is clockwise positive. I told you, so make a note. When the origin is changed, deflection y sign will remain same, but theta sign will change. If you take left origin, theta will be anti-clockwise positive, but whereas if you take right origin, see, it is what? It is clockwise positive. I told crystal clear earlier, that is the mistake. So that mistake correction you apply and get correctly, this is wrong, you will get C1, C3, what I wrote. I'll give you 5 minutes time, agreed? I'll give you 5 minutes time, agreed? Small break. I'll give you 5 minutes time. You correct, then I am coming back and correcting it. Then I will come back here and correct it systematically. I will come back here and correct it systematically, not just give idea. Okay. 5 minutes time. Get it fast. Just within 5 minutes, you should type the answer. Yes, corrected our mistake. We got correct answer. At least 1 or 2 more should comment. Okay, start. Now, I wire got entangled here. I don't know what happened. 1 minute. How it goes that way, first of all. It has gone fully inside here and has to come out. 1 minute. So wire. Now tell me, you understood what is the mistake you made? Tell fast. You understood what is the mistake you made? Fast. You understood what is the mistake you made? I will correct it now. This is to remember why these mistakes are made, so that people will remember. So many times I make mistakes. Why? Deliberate mistakes. Then I will correct it. Then before that I'll give a hint somewhere. Something I will write on the board. I know I am making mistake. Now fast. Clear what mistake you made. Is it clear now? You are not responding. What mistake you made? Or I did not make mistake. I deliberately made mistake. Or if you solve this way, clear or not? What is the mistake? The mistake is in what? Theta continuity. No, see, if there is no reply, I don't know. You should tell first. Is the mistake clear? That what mistake is made? I have to ask how many times? Okay, I'll wait. Till you answer, I'll wait. If you cannot answer the question, what I can do? I am asking the question since past 5 minutes. Then I will stop the class, that's all. I am asking only one thing. Is the mistake is clear or not? I will correct it. Yes, see, the mistake you should write. When you take left origin, theta is anti-clockwise positive. When you take right origin, theta clockwise positive. Therefore, see, you are right here. This is EI theta C when I take left origin in anti-clockwise direction. Whereas this is your EI theta C, you write once again in clockwise. You once again start from here. You write this much and cut it. Cut it, write the explanation, then write. This is, see here, EI theta C in anti-clockwise, that is EI theta C clockwise. But deflection correct. This is upward, this also is upward. That's why I put arrow mark. So both are upward, both are negative, no problem. Therefore, equate EI theta C and also on both sides and also EI YC. Then EI theta C for AC, see now. Now very important, I will remove this one now. Equate, see, I will again write here. See, first, right here. Note. One small example you can write. If I go this way, if it is plus 10, if I come from that side, it is plus 10 equal to plus 10. But theta opposite. If I go this way, if it is plus 10, if I come from that side, it will become minus 10. Sign convention. Answer is same. Therefore, if both are plus 10 or both are same sign, equate. When they are opposite sign, you should write what? EI theta C from left, see. EI theta C anti-clockwise for AC portion should be equal to minus of EI theta C clockwise for BC portion. Clear? See, one side you got plus 10, other you got minus 10. You should tell 10 is not equal to minus 10. 10 equal to or 10 plus minus 10 equal or you can do one thing. This way you can write, or you can write EI theta C anti-clockwise on left side plus EI theta C clockwise on right side equal to 0. First, this step is clear? First tell me. This step is clear. Since they are opposite sign, you should equate with one of the side. You have to, any side you have to put minus sign. Clear or not? You can write anything. You can write this ei theta is minus of that one, or you can write that equal to minus of this one, or sum of those two equal to 0. Clear? Therefore, what happens here? Therefore, you get, see, C1 plus 36 into 4 square by 2 will be equal to, when I come from that side, minus of what? Minus of, where is it? Minus of, where is ei theta, the other side? Here. Minus of C3 plus 24 into 6 cube by 6, or C1 plus C3. See, C1 plus C3 equal to, tell the answer, 24 into 6 cube by 6 minus 36 into 4 square by 2. Answer. Minus of 24 into 6 cube by 6 minus of 36 into 4 square by 2. Answer. Number. It will change. What is the number? It is not same as last time. Number will change. So theta, different sign convention. One should be negative of other one. Answer first. See, minus of 24 into, this will become plus this side. Minus of 24 into 6 cube by 6 minus of 36 into 4 square by 2. Number how much? Tell first number. See, again you are wasting time. You minus 24 into 6 cube by 6 minus 36 into 4 square by 2. For this one you require this much time. Minus 720. Minus 720. Equation number 1. And your equation number 2 will not change. See, where is equation number 2 I wrote? Okay, then this is first one. Then next, EIYC up for AC portion equal to EIYC up for BC portion. Why? Because both are same sign convention. Or I can write what? 4C1, where is it? First one? First one is 4C1 plus 36 into 4 cube by 6 equal to, how much it is? 6C3 plus 24 into 6 cube by 6. That will give you 4C1 minus 6C3 equal to 480. Equation number 2. Okay. Now solve 1 and 2. Tell the answer. First. Now solve, this all I will remove now. Now solve 1 and 2. Tell the answer. So solving 1 and 2, tell the answer. How much is your C3? How much is your C1 and C3? Answer. Solve 1 and 3. Now tell the answer. Solving 1 and 3. How much? C1. Now solving 1 and 3. C1. Now it will come same as what I told you earlier. What answer I told. How much? C1. Now solve. Fast. This much time to solve. C1 plus C3 is minus 720. 4C1 minus 6C3 equal to 480. C1 and C3. You are wasting lot of time. This way if you waste the time, it is difficult to take the class. See, no participation. You have to give the answer. I know answer, but let it come from you. I know the answer. Let it come from you. Then I can close this question. Say, same means you tell, okay. Your C1 will come minus 384 and C3 will come minus 336. Therefore, I write here, your C1 equal to minus 384 and your C3 equal to minus 336. Okay. Fast. Everything. This all I will remove now. Fully clear? Fast. If fully clear, I will go further. This all I can remove now. None of them required. Fully clear? Fast. Now you got C1 and C3. Now you can solve and get whatever you want. Fast. Clear. Okay. Now, see, one by one. what they want. See, first, now find whatever required. Start. First one, maximum slope they want. No problem. You know, simply supported beam will bend like this. Whatever is there. This is your theta A. See, I won't put arrow mark direction here. This is without direction, theta B. So, theta max will be, maximum slope means theta max. Theta max will be at supports, A and B. That is your theta max equal to either theta A or theta B, whichever is higher. Okay, now find one by one. To find theta A, now I won't use red color. To find theta A, substitute x equal to 0 in slope equation. In slope equation for AC portion. You get EI theta A in anti-clockwise equal to C1. Where is C1? Minus 384. That's all. Why? Minus 384 plus 0 over. Therefore, theta A equal to C, anti-clockwise positive, minus 384 means it is 384 by EI, that much radian in the clockwise direction is the answer for the correct. See now, elastic curve will go this way. If I draw tangent, theta A will come clockwise over. Now, to find theta B, substitute x equal to 0 in slope equation in for BC portion. Next time when I do by Macaulay's method, substitute x equal 10 meter. Why? There only one origin. In the Macaulay's method, to find theta A, put x equal to 0. To find theta B, put x equal 10. Somebody will ask, how same equation, adjustments are there? Okay, start. Therefore, use the slope equation for second one. EI theta B in what? Clockwise direction equal to C3. Where is C3? C3 is minus 336 plus 0. Therefore, your theta B equal to negative came, clockwise positive, 336 by EI radian anti-clockwise. Correct? Why? See, when the beam bends here, see here, your theta will be clockwise here, it will be anti-clockwise here. Correct. Now you can write the answer. Therefore, this also over now. Therefore, theta max equal to either A or B. A came more depending upon where is the load. This question A, 384 by EI radian, which is at A. Okay. Now, stop here if EI is not given. But in this question, given. See, now write, given EI equal to, tell me how much I given. I forgot. I rubbed the question. Tell me how much EI I gave you. I have given you EI. Earlier class I told you how to get EI in required unit. This time because of time problem, I have given EI in the required unit only. How much EI I told? 40,000. I told EI equal to 40,000 kilonewton meter square. You make a note. The question is so far solved in kilonewton and meter. Therefore, we need EI also in kilonewton meter unit. And fortunately, the person gave the value in the required unit because today he does not want to continue discuss on EI. It will come later or already came. So directly. Therefore, your theta max equal to how much? 384 by 40,000 radian. Tell how much? 384 by 40,000 radians. Very small. 384 by 40,000 radians is 0.0096 radian. Okay. 96 radian. That is, do one thing. If you tell somebody in radian, he won't understand. Convert to degree, tell the answer. Convert to degree. Tell the answer. Very small angle. How much degree? Convert to degree. Answer. You convert to degree. This I will not tell how to calculate. You should do it. Try. Convert to degrees. This radian, people won't understand. How much degree? I already got it. We got in radian. Tell me how much degrees? 0.0096. This much time. 0.55 degrees or almost half degrees. 0.55, 0 something is there. Okay, leave it. 0.55 degrees. Over. This will complete what? Maximum slope. Okay. Now, next, I'll continue one by one. Okay. Now, after maximum slope, what they want? Second, they want slope and deflection. Slope and deflection under the load. Under the load. Under the load means that is at C. Okay. At C. At C they want slope. See now. Now you have two options. See, right. Note, C is end point of AC and also end point of BC. If it is AC, x equal to 4 meter. If it is BC, x equal to 6 meter. So, to get the answer at C, we can use either equation for AC or equation for BC. Both should give same answer. Check it. Start. Now, first, let us find theta C and yc using expressions for AC portion. Substitute x equal to 4 meter. 4 meter. Right. First, in slope equation, in 4 meter, in slope equation, you get illi. EI theta C anti-clockwise equal to C1. Where is C1? C1 is minus 384 plus 36 into 4 square by 2. Tell this answer. Minus 384 plus 36 into 4 square by 2. What is the answer? Minus 384 plus 36 into how much? 4 square by 2. Fast. Important concept is there. That's why I am continuing. Minus 384 plus 36 into 4 square by 2. Again delay. See, this delay you should calculate immediately. Minus 96. Okay. Minus 96. Minus came. Therefore, your theta C equal to 96 by EI radian. We took anti-clockwise positive. Negative came that much clockwise. Okay. Now, next. See now. And substitute x equal to 4 meter in deflection equation. In deflection equation. What you get? For which one? For AC portion. EI YC upward equal to C1 into X. C1 is how much? C1 is minus 384 into 4 plus C2 is 0 plus 36 into 4 cube by 6. Tell the answer. I will tell you this answer has to come. I will not see anything. I will see only problem. This answer has to come 1152. Why means you don't bother. This answer has to come minus 1152. Tell the answer. If it is not coming tomorrow onwards, no class. It has to come minus 1152. Yes, minus 1152. Therefore, deflection at C equal to 1152 by EI. See, problem is solved in kilonewton and meter. Deflection will come in meter. And negative came means downwards. Yes, because upward positive negative. This answer. Now, or just for curiosity, substitute x equal to 6 meter in expressions for BC portion and again get what value? Again get theta c and yc. Okay. If the answer is not coming same, no more class will be taken by me. Start. First, substitute x equal to 6 meter in this equation. But be careful. EI, first slope equation. Slope. EI theta c, this time clockwise positive, equal to C3. Where is C3? C3 is minus 336 plus 24 into 6 square by 2. Answer fast. Minus 336 plus 24 into 6 square by 2. Answer. How much answer? Minus 336 plus 24 into 6 square by 2. If I use that equation, it has to come same. Otherwise, no class here. Minus 96. Or your theta c equal to clockwise positive, negative. No. I think plus will come. Ayo, plus will come. Minus, no, plus will come. Plus 96. Clockwise positive plus game 96 by EI radian clockwise. Oh, that is same answer we got. If it is a clockwise there, here also answer. Sign may be changing, but final answer is, see, to the elastic curve, if you draw a tangent here, the slope will be clockwise, guaranteed. Nobody in the world can change it. Right here. And use deflection equation. EI deflection at C upward equal to C3 into X. Where is C3? Minus 336 into 6 plus C40 plus 24 into 6 cube by 6. This also has to come minus 1152. Coming or not? It has to come minus 1152. It has to come. It has to come. Mathematics correct means it will come. But I am not checking. Came? Yes or no? Same. Minus 1152. No reply. Yes, same. Therefore, you can tell deflection at C equal to 1152 by EI meter down. Oh, right here. What answer you got? What you got? Both are same. Now, closing part. Why? Closing part means presentation. Therefore, your theta C equal to 96 by EI is 40,000 radian. Write the answer in radian, convert to degree. You only do it. Not required for me. You only do it. And deflection at C equal to 1152 by 40,000 meter. Tell the answer. It will come in meter first. 1152 divided by 40,000. It will come in meter. How much? 0.0288 meter. Correct? 0.0288 meter is the answer. But R equal to multiply by 1000, 28.8 millimeter. That is around how much? 10 meter span. See, around this much deflection. Reasonably okay. 28.8 millimeter. Okay, now these also over. Next, see what all they want. Then the next day I will give answer now. Now you calculate. See, I will give only answer. Homework now. Next, third, to find slope and deflection. Slope and deflection. Where? At the center of the beam. Center of beam. Put some name. Say, already I used A, B, C. Center I will call D. That is, if this is the beam, see, very important. If this is A, this is B, this is the point load is C, this is 4 meter, this is 6 meter, center of beam will come here. This is the D center. Therefore, from here to here is 5 meter. Tell me, substitute x equal to how much? Substitute x equal to fast. At center of beam, substitute x equal to how much? Substitute x equal to find slope and deflection at center of the beam. Substitute x equal to 5 meter. Now be careful. 5 meter, but very careful. Tell me, in expressions for AC portion or BC portion, now you should be careful. Otherwise, gone case. Shall I consider expression derived for AC portion or BC portion? In the expressions for BC portion, x from B. Okay, I'll give direct answer. Your theta center will come how much and y center will come how much. I'll give direct answer in degrees. You first get radians, then convert to degrees. C3 is how much? C3 is very C3, 336 minus 336 plus 24 into 5 cube, not 5 cube, okay, minus 336 plus 24 into 5 square divided by 2. You will get theta 36 by EI radian in anti-clockwise direction. It will come in, no, 1 minute, center will come here. It will come in anti-clockwise direction, or it will come, if I convert it, divided by 40,000, it will come in radians into 180 divided by pi. It will come 0.0515 degrees. And deflection at center is important. Use this equation. C3 minus 336 into 5 plus 24 into 5 cube divided by 6. It will come 1. Actually, first you will get a minus sign. That is upward positive. 1180 by EI meter down will come. Or when you substitute EI value, divide by 40,000, it comes in meter, convert to millimeter. It will come 29.5 millimeter. Okay, clear now? Clear or not? First tell me. All this clear? If all this clear, tell me. This all you have to work out now. All this clear? Substituting x equal to 6 meter. Okay, now, next they want, see, now they want next fourth one. See, fourth one. They also, where else they want? 1 minute now. Tell me, next what they want? Tell me. See the question there. Find maximum slope, already over. Find slope and deflection at load point, over. Find slope and deflection at center, over. Then, what they want? Theta will come negative, I written anti-clockwise. Why negative? I wrote anti-clockwise there, see. I have taken care of sign. When I wrote the answer, I wrote anti-clockwise. 1 minute. Yes, since I took right side origin, theta is clockwise positive, I got negative, I wrote anti-clockwise. See, I wrote the answer without sign. That already taken care. Okay. Now, what they want further? See, tell me. What they want further, tell me. See the question. Slopes at maximum slope over. And then slope and deflection at load point over. Slope at center over. They want maximum deflection. But I will do one thing now. Before maximum deflection, see, fourth one, extra. I will tell you, extra. To understand, see, extra. Find slope and deflection at 2 meter from left end, and also at 3 meter, not 3 meter, 2 meter from left end, also at 3.6 meter from right end. There is a reason here, because why? I am solving same question by Macaulay's method, same time. At that time, each and every answer has to come same. Okay, start. That is, say, 2 meter from left end, you call the point as P1, say P1. 3.6 from right end, say P3. Mark it here. This is the beam. This is the beam, A and B. Load is somewhere here. This is C. This is 4 meter. This is 6 meter. Now they want one point here, P1. Where is it? 2 meter from here. One more point they want here, P2, at 3.6 meter from here. See correctly. Tell the answer. To get theta P1 and y P1, this is homework for you. Homework. To get slope at P1 and deflection at P1, substitute, tell me, x equal to, answer. Substitute x equal to get slope at P1 and deflection at P1, substitute x equal to, how much? When I do by tomorrow by Macaulay's method, same point I will do, x will change. I have to get same answer. I have to get same answer. X equal to 2 meter. But be careful. 2 meter in the expressions for which portion? Here which portion counts? In double integration method. In the expressions for which portion? In the expression for which portion? AC portion. Why? Because your P1 comes here. So AC portion, I will give direct answer for you. Now you solve. What is theta at P1? What is y at P1? I will give you in terms of EI. Sufficient. No point in wasting time. Later, same I will solve by conjugate beam method and moment area method also. Remember, same points I will solve by Macaulay's method, moment area method and conjugate beam method. Everywhere answer will come same. I will make a note of this answer today. Okay, 1 minute here. Theta P1 is AC portion C1. Where is C1? C1 is minus 384 plus 36 into 2 square divided by 2. Theta P1 will come 312 by EI radian and clockwise will come. Deflection at P1 will come, any answer? C1 minus 384 plus 0 into 4 plus 36 into 4 cube divided by 6. 1440 by EI meter down will come. I got a doubt. No. It is not 1440. Where is C1 value? C1 is minus 384 into 2 plus 36 into 4 cube divided by 6. Oh, no, wrong. I can make out. I came to know it is wrong. Once again, I'll check it now. C1 minus 384 plus 36 into 4 cube, 2 cube into 2 cube divided by 6 minus 336 or 336 by EI meter down. This is the answer at P1. Got the answer? EI is not required. Got the answer correctly? Tell me. Slope will come 312 by EI radian. Deflection will come 720 by EI. Oh, 1 minute. Let me check it. Where is C1? C1 is minus 384 into 2 plus 36 into 2 cube divided by 6. Oh, 720. Ayo, I got doubt. 720 by EI meter down. Okay. Now, to get slope at P2 and deflection at P2, substitute x equal to, see, your P2 is here, x equal to 3.6 meter in the expressions for, tell which portion? Substitute x equal to 3.6 meter in the expression derived for which portion? In the expressions derived for which portion? X equal to 3.6. In the slope and deflection equation derived for BC portion. Why? Here. But remember, tomorrow's class onwards, by Macaulay's method, if you want P1, if I take A origin, x equal to 2. For P2, X is not 3.6 in next method. Tell me X value. Tell me. In next tomorrow when I solve, I will take A origin. That's all. So tell me what is the X value for this point tomorrow? For this point tomorrow, what is the X value? Tell me. What is the X value for this point tomorrow? It is not 3.6 meter. Why? Both the portion origin A only. Tell the answer. If I want here X equal to 6.8 from 10 meter, if you subtract 3.6, you are getting 6.8. You are substituting 6.4 meter tomorrow. But today when I substitute 3.6 meter and tomorrow when I substitute 6.4 meter, if answer is not tallying, I stop my class. Okay, answer. It will come, why bother? So answer is theta P2 and yP2, all of you correctly solve and get the answer. This is how you get the practice. C3 minus 336 plus reaction is 24 into 3.6 square divided by 2. Slope will come 180.48 by EI radian. It will come anti-clockwise. It will come anti-clockwise minus 180.48. I doubt very much. C3 is minus 336 plus 36 into 3.6 square divided by 2. Why this calculator is giving different answer? Why something wrong in the calculator? Feel like throwing it outside. Minus 336 plus 36 into 3.6 square divided by 2. Minus 336 plus 36 into 3.6 square divided by 2. 102.72. Nodi, allu chaukasi. 102.72 by EI will come. 180 point alla. Minus 336 plus 36 into 3.6 square divided by 2 is 102.72. Who told? It will come 102.72. Okay. Then deflection at P2 will come minus 336 into 3.6 plus reaction is 24 into 3.6 cube divided by 6. Deflection will come 1022.976 by EI meter down. Okay. Now, so that now you know how to find slope anywhere in the beam. Also you know how to find maximum slope. Then you know how to find slope or deflection anywhere in the beam. Whether it is this portion or that portion, even ending portion, common point. Now last pending is last but very important is to find maximum deflection. That is called Y max. Now time also counts here. I will see what is the time. Still 4 minutes are there. So I will do one thing. Principle I will tell tomorrow. I will finish this question. Why? Let me tell the principle when I go to Macaulay's method. Better. So that why double time waste? There once again I will tell. So there I will tell you long back. Shall I finish fast? Tell me. I will explain briefly. But too much explanation I will give tomorrow. Okay, no problem. More further explanation I will give tomorrow because I want this question to be closed now. Will do. If I discuss about Y maximum, it will take more time. 180, what is this theta P2? I don't know what is this calculator doing here. C3 minus 336 plus 24 into 3.6 square divided by 2. 180.48 is first time this is a calculator problem. It is 180.48. Okay, because that power and square are nearby. I press wrong button. Okay. Shall I finish Y max today? Okay, see now. Start. Lastly, Y maximum. C1, C2 require. I want C3 value only. Your C3 is how much? C3 is minus 336. Okay. Circle. See. Now, Y maximum. See, correctly, to get Y maximum, see, next class, more and thorough explanation. Thorough explanation. See, the beam is like this. Point load is here. The beam will bend like this. Okay. It will bend something like this. Okay, random. Okay. See, the beam elastic curve will go this way. Therefore, see, this is C, this is A, this is B. This is your YC. As you go that way, somewhere here is Y maximum. So first write Y maximum will take place in BC portion. In BC portion. Y tomorrow. Actually, I will take a scale here, bend it and show you. Anyway, remember, today you agree with me here. So let it be an unknown point. We don't know where. Okay. See, now, see, let this point be X. Distance from here is X. So if I draw tangent here, the slope at X equal to 0. See now, I will finish fast today. So that tomorrow I will explain. Y max will take place in BC portion. Let Y max be at a point X between B and C. Between B and C at X from origin B. There and at the point of Y maximum, dy by dx or slope theta at x should be equal to 0. Why? See, wherever y is maximum, the slope should be 0. It's a rule. All I will explain tomorrow's class. Okay, start. Now, therefore, first locate the point x. How? Where y is maximum and also theta is 0. What you do? Equate theta x to 0. Tell me. Equate theta x to 0 in the expression for theta for which portion? AC or BC? In the expression for theta for AC or BC. First. See, the point lies between B and C. In the expression for theta for which portion? AC or BC? For BC portion. Tomorrow I am explaining more because time is not there. Start. 0 equal to, see, you equate theta equal to 0. C3 minus 336 plus 24 into x square by 2 equal to 0. Therefore, you get the value of x. Tell the answer. X I want 4 decimal today, 4 decimal tomorrow, 4 decimal in moment area, 4 decimal in conjugate. All the 4 methods. Any method gives 1 micromillimeter difference, subject over. Start. X. Ayyo. 5.2915 meter. X equal to 5.2915 meter. So, the last now. I can remove all this now. I will explain more tomorrow. Therefore, y is maximum at 5.2915 meter from B. That is, I will tell you here, see correct, clear. This is the beam, this is that 4 meter, this is that 6 meter, this is center, see, this is your load point C, this is D is center, it is center is at what distance? 5 meter, it is somewhere here, little after center, before the load. Here, here. This is the distance 5.2915 meter. See, y is maximum here. These all tips I will give you tomorrow. Start now. Substitute x equal to 5.2915 meter in deflection equation. In deflection equation for BC portion. Start. EI y max. That y will be y max. Right? That y is y max equal to upward positive equal to, see, C3 into x minus 336 into x is 5.2915 plus C4 is 0 plus other one is 24 into 5.2915 cube by 6. Tell the answer fast. Tell the answer. Fast answer. Over. Today's last calculation. Answer. Substitute that value. It should come more than the load point and more than center. Why? This is the maximum deflection. Answer. X equal to 5.2915 meter. Fast, fast. Don't waste time. 1185.30. 1185.30 minus is the answer. Minus will come. Correct? Minus 1185.2996 is 30. Okay. Therefore, I will close the question now. Therefore, maximum deflection for the beam that is y max equal to 1185.3 by EI meter downwards, where at 5.2915 meter from B, or equal to 1185.3 by 40,000 meter. You write in meter or convert to millimeter. Okay. Now you can do it. 1185.3 divided by 40,000 meter into 1000. It will come 29.6325 millimeter. 0.296. Okay. 29.6. Over. Answer. Now I will tell today only. Tomorrow I am solving this question by Macaulay's method. At that time, my x is from A. My x is from A. Even for BC portion also, x is from A. So tomorrow's class, y max, x from A should come. Tell the answer. Tomorrow's class, when even this point, I am taking x from A only. So it has to come tomorrow. Otherwise, day after tomorrow onwards, no class. Tell me. Tomorrow, when I take A origin, for both portion A origin, how I manage, I will tell you. How I manage, I will tell you. See that discontinuity, I will tell you how you manage. There is double integration method. Macaulay's method. But x has to come. I will write now 10 minus 5.2915. 4.7085 meter. Correct? It has to come 4. I'll write here. I will not remove 4.7085 meter. Tomorrow it has to come. Now, I am not removing this one. This tomorrow when I rub the board, full I will rub. This I am not rubbing. When I get x value, if this corner is not visible, I will turn the camera and focus on this value. I will ask you, yesterday decided, is it the same answer or not? If it is the not same answer, no more class will be conducted by me. Agreed? Are you agreeing? If the answer is not coming, tomorrow I am going to stop my complete education, what? Structural engineering education. No problem. Are you agreeing? Will you agree or not? I will not continue one single class. I will go to native place and start agriculture. It has to come. See, someone committed. It has to come. What else? It has to come. No. Anyway, just for fun I told, I will not stop because if it is not coming, something wrong here. That's all. Something wrong here. Otherwise, structural engineering, strength of materials, engineering mechanics, or structural analysis, theory of structures, matrix method, finite element method, all such things never happen. RCC steel, because of approximation, something may happen. Basic subject difference will not come. Okay. Continue tomorrow. Tomorrow onward, serious class, Macaulay's method. Remember, this is going to be stopped now. This headache of what? Taking different origins, struggling, nothing is there. Unique procedure, very simple. Very simple. See tomorrow. So you will it will become simple because once you go through a tough question, then you enjoy it. Oh, you will tell how nice. Otherwise you will tell that also difficult. Since you have gone for a tough one, that becomes very easy then tomorrow. Okay, thank you. See you tomorrow.